Okay guys, this is going to be part 2 of our proportional relationship video. We got cut off last time because it only has given me a 15-minute time limit. So, alright guys, let's try to figure out what the equation is. So we have our graph, it's in a straight line, we have our x and we have our y. So we know our equation is going to be y is equal to, so let's figure out what our coefficient is by looking at what our rate of change might be. So if we have 35 to 70, we added 35. And to get from 5 to 10, we added 5. So our change in y over our change in x, so 35 over 5. I'm getting these numbers from here. So this is my change in my y, which was 35, and my change in x, which was 5. 35 divided by 5 is 7, so my coefficient is also going to be 7. And my x will stay a variable. So if we plug this in, y equals, so 35 would equal 7 times our x, which was 5. And I could pick any of the values here and plug them in to make sure my equation was accurate. It doesn't have to be the first one. It could be the middle one if I wanted it to. Let's look at this one. So 140 would equal 7 times 20. 7 times 20 is 140, so my equation is correct. So let's discuss if this is a proportional relationship or not. It's a straight line. Okay. We know that we have an equivalent ratio of y over x throughout. And we also know that this passes through the origin. So this is a proportional relationship. If we look at the bottom, we are going to read each scenario and determine if it is a proportional relationship or not. If it is proportional, then we're going to write an equation. So remember, it's proportional if it would form a straight line and if it goes through the origin. So the origin is 0, 0. So remember, if we're multiplying something by 0, because these are all multiplicative relationships if they're proportional, remember, kind of keep that in the back of your mind. So for 3, a restaurant charges $10 for a medium pizza and $1 for each additional topping. So $10 plus $1 per topping. Okay? This is not a proportional relationship because that $10 is what we consider an initial value. Okay, so this is not proportional. We're going to talk a little bit more about this next week, but just try to keep in mind if there's an initial value, it is not a proportional relationship. Number 4, a restaurant has an all-you-can-eat buffet. They charge $8.75 per person. So this is proportional. It would be y equals $8.75x. If x was one person, $8.75 times 1 would give us our y. If x was 2 people, $8.75 times 2 would give us our y. Number 5, so this one, yes, is proportional. I'm going to write that as well. Number 5, a restaurant charges $1.50 for a fountain drink with free refills. So this is y equals $1.50 times x. One drink would cost $1.50. 2 drinks would cost $3. This is a proportional relationship. Don't let the free refill part confuse you. It's not costing us anything. Number 6, a restaurant has a build-your-own salad option. It is $3.80 per pound of salad. This is proportional. Y equals $3.80 times your x. If I'm not buying any pounds of salad, right? So 0 pounds, $3.80 times 0 is 0. So it would go through my origin, right? My x and my y would both be 0. So it is a proportional relationship. I could have said the same thing here. If I don't buy any drinks, it's not going to cost me any money. So it would pass through my origin. A vehicle travels at a rate of 65 miles per hour. This is also proportional. Y equals 65x. In 1 hour, 65 miles. In 2 hours, 130 miles. Okay, that is a proportional relationship. All right, guys, so I'm sitting at about 5 minutes. So what I would like for you to do now is to look at the next slide, which I believe would be slide 13. I want you to try to complete this on your own. Okay, so pause my video right here. And then when you are done completing this on your own, when you're done attempting it, I want you to come back, unpause the video, and I will go over this proportional relationship with you. So go ahead and pause right now. All right, guys, welcome back. Remember, it was your job to try and do slide 13 independently, and then you were going to come back here and check it with me. So again, we have our representations. We have a table, we have a graph, we have a verbal description, and we have an equation. And then we're going to try to determine if the relationship is proportional or if it is not proportional, okay? So we're going to use the information that we have. The only information that we have right now is our table. So I know that 2 hours is $24, okay? For whatever we're renting costs $24 to rent. So that would tell me that maybe for, if I go from 2 to 1, I would divide by 2. So if I do the same thing here, 1 hour would cost me $12. So if I don't have any hours rented, I haven't spent any money, so 0, 0. 3 hours would cost me $36. 4 hours, $48. 5 hours, $60. 6 hours, $72. 7 hours, $84. 8 hours, $96. And 9 hours, $108. And remember, if Mrs. Brown went too fast through any of this is a video, so you can pause and rewind as much as you would like. Okay, so my hours rented is my X. My total cost is my Y. Hours rented. Okay, and then this would be the total cost spent on the rental. So we would go 0, 1, 2, 3, 4, 5, 6, 8, 9, and then we could go 12, 24, 36. Our increments for this could be 12, 48, 60, 72, 84, 96, 108. So in 1 hour, 12, 2, 24, 3, 36. And remember again, if I'm going too fast, because I'm trying to keep within my 15-minute time limit, you can pause the video at any time and try and catch up. So 7, and 84, 8, and 96, 9, and 108. It is a straight line that passes through the origin, so keep that in mind when we go down here to talk about proportionality. Okay, so my equation, y equals, if I look over here, from 0 to 12, I've increased by 12. From 0 to 1, I've increased by 1. So my change in y over my change in x is 12 over 1. Okay, so my rate of change is equal to 12. Y equals 12x. Okay, so for my verbal description, I could say anything. I could say whatever I'm renting is going to cost me $12 per hour. Okay, it could be a bike, it could be a surfboard, it could be roller skates, whatever. As long as you are doing some description about something that is being rented. So something is being rented at $12 per hour. That's our verbal description. Okay, let's look and see if it's proportional. It passed through the origin. It's a straight line. And our ratio of y over x, or our constant of proportionality, is the same throughout. Okay, is equal. So it is proportional. Okay, now we're going to use this up here to answer these questions. The bike rental company has determined that they will charge based on the nearest half hour. If Micah rented the bike for 5.5 hours, how much would that cost? So we have 5.5 times 12. Okay, well, I know that 5 times 12 is 60. Half an hour of that would be 6, so 66. Let's see if I'm right. 5 and 5, 66. Yep. So it would cost $66 to rent for 5.5 hours. At what does the point 784 represent in this situation? So it's 7 hours, and that would cost $84. Okay. The bike would be rented, so the rental of 7 hours, and that would cost $84. If a customer has $50 to spend, how many hours can they rent a bicycle? So they could rent the bicycle for 4 hours, because that would cost $48, but they don't have enough money to rent for 5 hours. Okay, so that's the end of the proportional relationships. I'm going to come back. I'm going to make another video for non-proportional because we are at 11 minutes right now. So stay tuned for part 3.